let's get to the topic. So yeah, I've been building stuff for web for quite a long time, and I started with CGI scripts and ASP pages and so on. But for the last, let's say, 10 years, I've been mostly using React. And in many of my projects at Reactor and also before that, there has been some kind of collaborative aspect to the application. So users work together on the same piece of data. And now, if you think about today's applications, like what kind of applications come to your mind when I say collaborative applications? Name a few.
Figma.
Figma, yeah, for your designer, right?
No.
Notion.
Notion, yeah. Google Docs, that kind of stuff. And like Miro and those applications where you can you get a real kind of feel of collaborations. You see other people's cursors going around and you see what they do in real time. How many of you have actually implemented an application like that? Good to see a few hands, but not so many. And I didn't used to do it that way either. Until recently, like a couple, maybe it was 3 years ago when I built this thing that you see on the screen. This is called Our Board, and it's a bit like poor man's Miro. It's worse, but it's free, and it's open source and so on. So the thing was like, can it be so hard to build your own Miro? Why would you pay for a Miro while you can just hack something together with React? Well, turned out it wasn't so easy, actually. But let's start from building something a bit easier. Like, how many of you know Trello? Almost everyone knows Trello. So it's an app for like a Kanban board, a virtual Kanban board thing, where you can add tasks and move them around different lists. And like I've seen it many times that you start working on something, you build a REST API, you build a front end on top of that, you use some RESTful calls for updating and creating new data, and then okay, it needs to be collaborative. Let's add collaboration. Yeah, okay, like polling, right? Pretty simple thing. You just pull new data every 5 seconds, and it's almost collaborative. You can do that. I think you could build a Trello with an approach like that, and it wouldn't be too bad. Yet there are of course some kind of gotchas with that. Like obviously polling interval, you don't want to poll a huge thing every second. You will have to find kind of compromise. But then I think the more relevant problem is that you need to deal with dirty state. Like if a user is editing on a text field and then somebody else makes a change, then how should you deal with that difference? And how do you deal with changes when they come from the current user and changes that come from the web? That's a bit challenging. So it kind of that approach doesn't get you far. It's like adding an aspect like afterwards, like adding security afterwards or adding usability afterwards. It doesn't work very well. So I would say that if you want to build your own Trello, you might still maybe think again before using REST and polling. Now, if you were building a Miro or Figma or something like that, and you want to support like 20 simultaneous users on a single workspace, and you want to see those cursors flying around and so on, then it's pretty obvious that you can't just do REST endpoints and polling. So something you might want to try is event sourcing, or the same idea that you have used in Redux. Have you used Redux? Most people have, yeah. So you have these events that represent some change, like user created a new node, and then this event is dispatched not only for the local UI, but also via a WebSocket or something like that to all the clients that are using the same workspace. And then the reducer will then calculate the next state based on this event on every client. That's a pretty nice approach, I think, and it works to some extent. And actually this application I'm using here is based on that approach, the kind of distributed reducer and events thing. But, well, obviously there are challenges. And you know, they are at first things look like, yeah, this is a very nice approach, no problems here, just distributed events. But what about event ordering? Like, it of course happens when you have 20 users doing stuff all the time. Events will appear at different time, a different order at different clients. So of course you might do your best to make your reducers somehow predictable in the sense that the event ordering shouldn't matter, but it's a hard thing to do if you keep on increasing complexity and new features. You always have to think, what if things happen in a different order? And also, of course, conflicts come in the way. Some people work on same data. How do you resolve those conflicts in a way that the end result looks the same for every user? And then, like, state initialization problem is that when people are working on the data, they are clicking around, and then another user joins the same workspace. How do you synchronize state so that the new user gets the same view as the others while things are happening during this initialization phase? So kind of you can't just use a REST endpoint and then some WebSocket event, because you have to handle all those events that happened during the REST call. It's surprisingly hard, but I did it. It's complex. I ended up using things called shadows. So you have a server shadow model on the client. So it kind of models the current state as on the server at the moment, and then you reorder events so that they will happen at the same order on every client. Very complex and very fancy, complicated, and you know, every time I make changes and add new features, I will have to think about all these complex things every time again. How does this new event, how does it work in this complex scenarios? Hard work, fun, but you know, well, nowadays I don't have so much free time for coding, so I might want to look for something easier to do the job. So yeah, fun but hard. Then what if you wanted to implement Google Docs? You know, collaborative text editing. It's once again a different problem. You might think that it's the same problem, but it's not, because if you have like an array of objects or a hash map, you can express things like, okay, add this new object at this key, or change this property of this object. So it's easily addressable, the data. But if you consider rich text or just plain text, people are working on different locations of the text. So how do you kind of express each change so that you can replicate these events so that you will have a consistent view on each client? So like insert letter M at index 23. Well, that's a good try, but if somebody else inserted something at index 10, then, well, the new insert will be in the wrong spot. So that doesn't work really, and that gets kind of above my level of competence easily. So I just gave up and started Googling. It's a good idea sometimes to Google, and I also asked people on Reactor Slack, and that's where I was pointed to the right direction, which is CRDTs. That's the next slide. Yeah, CRDTs, cool. So CRDTs, they stand for conflict-free replicated data types. So it's basically a thing that keeps track of this stuff, so you don't have to. And Y.js is a library that implements these CRDTs in JavaScript, and it makes your life easier. So practically, in Y.js, you work with a document. So document is the main thing, and if multiple people are working on the same data, they are sharing the same document, and the changes between the documents on their clients are synchronized somehow by magic. And the document in Y.js, it's not limited to like rich text editing. It's a arbitrary hierarchical structure. So you can have like JSON like data trees, and you can embed these rich text parts in the document. So pretty much anything you can represent with JSON, you can represent in a Y.js document. Plus, you can represent these rich text things. It's pretty nice. So if you had this kind of a Miro kind of thing going on, you could model the whole Miro board as one y.map. So y map, it's a collaborative map, like a hash map thing, and then in that map you would have for each like post-it note you would have a separate map that represents that particular post-it note. And the text content of each node would be then a y text thing inside this map that represents that node. So it's for anyone who has worked with hash maps or basically any mutable data hierarchical data structures in JavaScript or Java or C# or whatever. It's a very familiar kind of structure, and it's very easy to operate. You can just manipulate data like in any data structure. You don't have to be thinking about will this break collaboration, how will conflicts be handled. You don't have to worry about that when you are working on the data, which is nice. You kind of separate those concerns. And so if you build an application using Y.js, you might want to use React for the UI, but it could be anything else. Y.js as a library, it's in no way kind of tied to React or actually anything. It has like zero dependencies practically. But you can build your own React hooks, or you can use somebody else's React hooks to tie it to React. Then you can use an editor component, for instance Quill, but there's a bunch of other rich text editors, and you just need to find your Y.js provider for not a provider, but an adapter. Binding, I think it's called, binding for that editor. So you can use your favorite editor and bind it to Y.js. Also Monaco is supported, which is the same editor that's used in Visual Studio Code. So you build your UI, you build it on top of the data model. So the Y.doc is your data model. Then you use a Hocus Pocus provider. So that's not the only alternative, but it's a pretty good one. So you can use the Hocus Pocus server on the server side and the Hocus Pocus provider on the client side, and those things are kind of for dealing the WebSocket connections, because you need to manage the connections between the clients and server and make sure that all the clients are synchronized. So Hocus Pocus is a kind of provider and server component pair that takes part of that. So it's kind of plugged into your Y document as a provider. So different users see the other users' updates. Then if you want, you can add offline persistence using Y-index-db. So you can work offline and magically, if you make changes while offline and then you connect again, all those changes will be replicated to other users and on the server side, and all the conflicts will be resolved also magically. Of course, the magical approach to conflicts is not necessarily perfect. Of course, it can't be, but it usually, according to my experience, it usually preserves the user intent pretty well. Of course, if two users kind of somebody adds something, somebody edits something, and another user deletes it. So what's the end result? I guess the deleted state would be the end result in that. But it won't make the other users happy if they wanted to kind of preserve the data. So magic is limited in its usefulness. But yeah, so this kind of architecture would serve you pretty well. So you have a server-side thing, you have WebSockets connecting the clients and the server, and then you could have PostgreSQL for persistence or anything. It's kind of, once again, the Y.js library doesn't consider itself with things like persistence. You can select your own solution for that. It's basically just binary blobs that you need to shove somewhere and then pull. back from somewhere. So yeah, so it's binary packets that are being sent over the wire. So that's how you build the application on high level. Now if we come back to the challenges with the distributed reducer approach, and think about them with a CRDT solution. You don't have to care about event ordering. So the algorithm that's used by any decent CRDT solution should be deterministic. So no matter which order things happen, the result is always the same. And if there are conflicting changes, you don't run into any kind of crazy conflict states like maybe someone used to run into when using Evernote back in the day. You edited the same document on two devices, and the result was that you had two documents and some conflict thing, and there was no way to solve it. But nowadays, Evernote is using Y.js, but I don't use Evernote anymore. Does anyone use Evernote? Not anymore. Yeah. They kind of failed, and they tried to fix it too late, I guess. But yeah, nowadays I hear they're using Y.js. So, and also this kind of complex initialization things like how do you connect a new client to a very busy document? It's all handled by the protocol. The Y.js library defines a protocol for how things should be synchronized, and it just works. If you want offline mode, you just add another plugin. For instance, the Y-IndexedDB provider that will kind of it will treat your local storage like any other peer. So it's able to sync the changes between the local store and the remote database or peers. Yeah, and you don't have to kind of care about update granularity. Usually, if you were writing your own like REST backend, you would have to think, what's the granularity? Do I update this whole thing at once, or do I make separate endpoints or some ways to update a certain field? That's a lot of work if you have to consider those things for each field and object in separation. But in this case, you don't have to do that because there's a protocol that deals with very atomic small updates at a time. And like revisiting decisions when data model evolves, no need. So if your application structure changes, you add new fields, you add new kinds of things. Like in your Miro board, you add support for, let's say, SVG images, something like that. You don't have to make any changes to your backend or any changes to the layer that is dispatching the changes between the different parts of your system. It's all part of the protocol. You just add new stuff to the document, and it's automatically supported everywhere. So I found that a great thing for productivity. So usually, if I work on a Y.js application and I need to add a new feature, it's often so that I don't have to do anything on the server side. It's all on the client side. Then of course you have to think about like schema migrations and stuff like that. That's of course you have to do, but you would have to do that anyway. Performance is awesome. You have to take my word for it. It's just awesome. Blows you off. So yeah, awesome stuff. But then, how do you like implement persistence? How do you make decisions like is this the right solution for you? I'm like preaching like a preacher here that it's the best thing ever, which it is for the domain that we are talking about, like collaborative web applications. It's awesome. But in a nutshell, so Y.js is a CRDT library. It's written by a guy called Kevin Jans from Germany. I have met him on Google Meet, and this might be one kind of a pitfall of the library. It's actually written by one guy, and it's amazing. But it's very good. I have never found a single bug in the library. There's never been a situation where we are like, okay, we need the new version of Y.js. No, it just works. A lot of the other infrastructure around it, of course, it evolves like the hocus pocus things. You can kind of, you know it from the name already that it's kind of it's a bit patchy, but main library is very solid. Kevin is working on a new release. I'm not quite sure what's going to be in it, but I suppose it's going to be great. He has his own way of working. He's like the main branch of Y.js on GitHub is broken. It's always broken, but it's okay because it's the main branch is the kind of the development branch for the next release, and then there are like these patch release branches which are not broken. I don't work that way. He works that way, but he makes great software. So, and I don't have to pay for it, so I'm happy. Yeah. Yeah. So, should I use it for my application? Should you use it for your application? I think that's the question you want to ask. And here are some kind of anchors, like, are you working with real-time collaboration? Is there going to be collaborative text editing? If that's going to be there, you definitely want to do it. You don't want to try to make collaborative text editing by yourself. It's just mad. It's so easy with Y.js. If you want offline support, if your data model is complex and it evolves all the time, if you want to have fancy things like seeing the cursors flying around and so on, well, then it would make sense. But if you are not doing most of these things, then it might not be useful. Because I think the kind of main gotcha here for your application architecture is if there is a document, then it makes sense. But if there is no document, it's very hard to use this library. Because in this architecture, every user has a full copy of the same document. And for instance, if you think about like Google Docs, well, the document is the document. If you think about Miro boards, the board is obviously the document. If you think about Trello, the Trello is it workspace or whatever, that's the document. But if you are working with like a hotel, let's say a hotel reservation system, what's the document? I'm not quite sure. Would the room be the document, or the hotel be the document, or maybe the hotel company be the document? I'm not quite sure. And if there are things like not all users should be able to see everything, then it's once again it's hard because the whole thing is built on the assumption that every user has the full copy of the document, and it doesn't work any other way. So if you can't find a document that can be shared with all the users, then it won't work. Go ahead.
Can the document be anything? Can it be like a web page? I mean, like a part of a web application?
Well, the document is just it's a data structure.
Yeah.
It's a shared data structure, and you can decide what you put in it.
So you can put HTML in it?
Yeah, you can put HTML in it, but I would question if it would make sense.
Yeah.
Like if you want like this collaborative text editing thing with some formatting and that kind of stuff, then you would probably use an editor like Quill, and then you would probably use the y.text data type for that because it's collaborative, and it can be rendered into HTML. But it's not like full HTML implementation in itself. And you can embed what they call blots in it of any kind. You can embed data in that, but then you kind of lose the collaborative aspect on those things. So kind of, yeah. For text, use text and then maybe render it as HTML. But mostly it's pretty arbitrary, the data you can put in it. But if there is no document, then well, then it won't work. We would have to think of a way to kind of find the document in your domain. Go ahead.
I mean, technically, a React DOM or component tree is just pure data. So you could do something really naughty, like make the React component tree your Y document, and yeah, but maybe don't.
Yeah, because you can encode anything you can put in JSON. Yeah. You can put in a Y.js document. Yeah, you could do that.
But maybe don't.
Yeah, I'm not sure if it's a good idea, but I don't know your use case. Maybe you have to do that. So the document is the thing, and then another thing that's a kind of a gotcha is that you need to persist binary CRDT updates. So so you will have to store your data kind of primarily in the YJS format. If you want to store your data in like a normalized SQL tables, well, it won't work so well because for the collaborative aspect of these documents to work, it needs to store all the YJS stuff. It's not like a JSON document. It's binary magic, and you have to store each of these update package that kind of are created for every user interaction. Well, you can either store all of those updates as a sequence, or you can create one big update for the current state of the document. Either approach will work. But in any way, you have to store the CRDT stuff. Or if you don't, then you will lose the kind of the time continuum and the collaborative aspect of it. Of course, you can do redundancy in the sense that when you save the document, you will also save some fields in some other database tables if you need to like index your stuff, for instance. You can, on every save to the database, you will save the CRDs, but you will also save like text contents in another table so that you can make a nice search functionality to your application. But you still have to store the CRDs. That might be an issue in some cases. So that kind of, for instance, if you would like to use Y.js with a WebDAV backend or something crazy like that, so that your storage would be in some other format, then it doesn't work. You need to store the CRDTs. Okay, so that's probably a handful of information already. Feel free to ask any questions at any time. So the document is the thing, and whenever you make a change to the document, Y.js will emit events locally. Like you can observe the changes to any part of the document, like using typical event listeners almost. And you can build your React hooks on top of those events or integrate to any kind of UI library you want. And also, whenever a change happens in the document, it will also emit an update, which is a binary packet. And these updates are the things that you will have to store or deliver to all the other clients viewing the same data. Yeah, I kind of covered the persistent part already. I have used PostgreSQL for storage, and I think it works pretty nicely. And if you store all the updates, like always just append a new row to the database, it's a nice storage model in my view, in the sense that you never have to do an update on the database. You will never destroy any data. The full history will be available to you. And to see the latest state of your document, you just replay all the events from the database when you load it to memory. Well, you can do any kind of, you can merge them by day or whatever. It's pretty simple. Y.js has these utilities for managing storage. Yeah. TypeScript, a bit of bad news in the sense that the typings are not optimal. The typings are, they resemble like hash maps. You know, like it's Y map is a map from string to your given data type. But if you want to represent a document that has kind of structure, so like you have fields with certain names, and some of these fields have a certain internal structure. That's usually how you define types in TypeScript, for instance. Well, the types for Y.js, they don't support that. There are alternatives like Y.js -types, or the types that I wrote for my own demonstrations and applications. Those are alternatives for that. And this may or may not be an issue for you. It depends on what kind of application you're writing and what kind of architecture you choose for your data layout and so on. It's pretty easy to write React bindings, or I think there are libraries on the internet also that you can use. I think it was Y.js React or something like that provides you this React bindings for Y.js data structures. But of course I brought my own. And when you write your own, you get what you deserve, in the good and the bad. Scaling things up, of course, you know, if you want to make an application where like 100,000 people are working on the same document, it's gonna be hard, and that's also why you have to choose your document wisely. But as long as there are like hundreds of users working on the same document, then it's not an issue. But of course, the WebSocket approach, like you have clients working on something and they communicate to the server and other clients via WebSockets, that requires a stateful server. So that's something to keep in mind. So often we nowadays like to write stateless servers, like use Kubernetes or whatever to launch lots of backends, and then you don't have to care which backend node your request goes to, right? But if you do these collaborative applications, you need to make sure that all the users are connected to the same server node, so that they will see the same state. Or then you will have to come up with some kind of replication schemas between the different servers, and complexity kind of goes up. My solution so far has been to use dedicated servers in the sense that all the users that are working on a certain document are routed to the same server node. So you can use hash routing or something, whatever your load balancer layer supports, to make sure that the user of the same document go to the same server. Then you can scale infinitely as long as there are not like a million users on the same document. So you can create your own Miro or Google Docs easily with this one. At least the scaling won't be the issue, right? If you have money. Okay. Yeah. How am I doing with the time? Couple of minutes. Cool. Let's have just a quick demo. So here is a code sandbox, and we have two instances of a document view here, and when I type something here, it's replicated to the other one, right? You see? I can add new items, and they are replicated to the other view. So this kind of simulates two user scenario where you can work on data. Works nicely. Just a quick view at the application code. So from top to bottom, like here is how I initialize a new document in Y.js. This create typed YDoc thing it's just a helper to make the types a bit nicer. How do I go back? Okay, like this. So I create a document, and then in the document I create an array. Pretty easy. Create an array in the document for all the items. So the items are the things in here. Then I create one example item. So create the type YMap is just my helper for creating a new YMap, and then I add some fields there, and I push it to the items, and then I have my kind of initial document state. So it's pretty easy to work with the data. Then in my application I create two documents, and then this is the synchronization mechanism in all of its glory. So I create one board and then another empty board, and then I apply one Y.js update from one board to the other. So I encode the state of one document as a binary update here, and then I apply the update to the other one, and then they are synchronized like that. And then I set up listeners for both of these boards or documents, and apply updates from each other to the other one, so they will be synchronized. So these two UIs here, they are actually they are working on separate Y.js document, and they are synchronized via the binary updates. They are not using WebSockets though. It's just on the client, but I'm kind of simulating the WebSockets on the client side setup. Right. And here is the board view, which kind of represents this thing, the user view of this single board. And adding a new item is just creating a YMap and pushing it to the items. So you can work with the Y.js data like any normal mutable data structures. So in the application code, I don't have to consider concurrency or a collaboration at all. So the rest of the application is just normal React code with some simple bindings to bind these Y.js data types to React. So he has to use Y field thing that kind of maps a field of a Y.js map into a React state like thing. So you can read the value and write the value, just like with a use state in React. It's done using use state, which is a bit suboptimal, but it does the job. So this kind of stuff. Do you have any questions?